Noon, everyone, and welcome. The time is now 12:01 p.m., and I'm your host, Dr. Matthew Richardson, and this is another stream of the Daily Space. Um, Andreas and Pamela are currently away right now, so I'm filling in for them. And today I will be bringing you two stories, two new stories from for today. Um, and first up, we have this instrument that we see here before us. But you know what? Before I begin getting into all of that, I always like to make sure that everything's going well with the stream here. And it looks like everyone can see me. Hey Guido, hey Tom. So for today we start our stories off with the instrument we see here before us, which is the Gatini IR. This particular instrument just was recently commissioned, and it was built by astronomers at the Australian National University and astronomers from Caltech. And so this particular instrument is going to be the first of its kind to be able to study the northern sky in search of new cosmic events. Um, the particular wavelength range in which this instrument is going to be studying in is the infrared, and this is going to be very important because we're not going to be able to see a lot of things that we couldn't see before or we haven't seen before, such as, for example, as stated here by the news article. By creating a real-time mosaic of the northern sky every night, we'll pick up lots of fascinating objects and dramatic events, such as the final throes of dying stars obscured by dusk, and detection of some of the oldest stars in our galaxy. So that makes sense, yeah. An infrared telescope, being able to see really um, cold stars. Also, another interesting thing that's stated within this article is something that's related to what we were talking about in the last stream, actually. And the idea that, as stated here in the article, in addition to letting us see through clouds of dust, infrared light can tell us a lot about the formation of heavy elements, such as gold and platinum, and neutron star mergers like the one ANU researchers and others were fortunate to observe last year. So, this particular instrument seems like it's going to be a good addition to the many instruments we currently have to be able to observe astronomical events at other wavelengths. And so, I guess we look forward to seeing what sort of research and science they get from this instrument. And so that was the first story, very short, quick. The second story that I'm going to bring up today, hopefully we can spend a little bit more time talking about. And this particular story is all about planet formation. So let's do this. All about planet formation. Being able to study, well, more specifically, being able to study star systems that are outside of our own, and seeing, the interesting ways in which the interesting dynamics and types of astronomical bodies, that is, planets that orbit stars that are, of course, external to our own. Um, and so, with the second story, right? With the second story, this particular image is not directly related to this story. This is just a animation that I was able to grab online. However, a team of researchers very recently actually discovered a relatively young star, roughly of the age of like 2 million years old. The name of the star is Ci Tau. It's roughly located about 500 light years away from us. And surrounding this particular star are four fairly heavy planets. According to the article, there are two Jupiter-sized planets and then two Saturn-sized planets um, that surround this particular star. Now, given its young age, though, there's also a protoplanetary disk. And in fact, for three of the stars, they were only able to discover those three stars due to the fact that these stars have curved out circles in this disk of composed of dust and ice. But one of the very interesting things about this particular system is that the very closest star is a hot Jupiter, meaning that the size of the star is on the order of a Jupiter mass planet or greater, and the hot part of that, the hot Jupiter, meaning that its surface temperature slash atmosphere is hot due to the fact that it's very close to its host star. Um, but the article's noting that what's very interesting about this system is that one, it has a hot Jupiter, um, but two, it has a Saturn-sized planet that is located relatively very far away from the host star. And the particular distance that this planet's out at is abnormal compared to other systems that have been observed. One and two, the age of this star is also very peculiar in that this age star has these types of planets surrounding it. And so I'm going to take a moment to like look at some comments here. I'm going to talk more about this, but I'm pretty sure I've been missing some comments here. Yes, I love Pamela's animated intro. It's great. I wish I had one of my own. Let's see. And so that's a great question, actually, Hanny. So what is it? What is this type of star? This article that I'm reading, the news update from does not indicate the type of star it is. However, it does give its name, Ci Tau. And so let's see if we can quickly do a quick search for Ci Tau and see what we get for it. Um, oh, well, it's a Titore star actually. So it's not. So it's if I'm not mistaken, Titore stars aren't even on the main sequence yet. So they're yeah, it's a very young star. That's what they mean by that exactly. And another question: as we take longer exposures of exosolar planets, wouldn't we expect to see larger planets farther out? Um, that's a great question, actually. Typically, the ways in which I could think of a planet being observed is one of three ways. Um, you can observe them photometrically. That is, as the planet passes in front of the its host star, it will cause a dimming. And so I guess that would kind of be related to what you're talking about here. And then the other two ways, one of them, the other way would be spectroscopically, being able to see the planet wobble over time due to the fact that it has a planet or planets orbiting it. And then the other like really really rare way of seeing it would be like through some sort of like gravitational lensing of it. Even if you even if you were to increase the exposure time of a system that has an exoplanet, I think it's really heavily dependent upon the um the relative size ratios of the planet and the star, and that's going to be based off of course, how close the planet is to the star. If it's a really really far out planet, I think it's going to be extremely hard to see, or yeah, the amount of dimming that you get from the planet is going to be less compared to if you were closer. So it's really important to know exactly, or really really important to think about the relative sizes of the planet to the star and how close the planet is to the star. Not so much about the exposure of or how long you're actually observing the system. And then also of course your detection limits for your instrument. So when you say not on the main sequence, not kind of, yes, when I say not on the main sequence, it's not categorized as one of those types of stars, those stellar types that you've noted there. But yeah, Titori stars though, if I'm not mistaken, are pre-main sequence stars. But all right. So what I wanted to get at with this particular story was well, I've actually like noted some of the key things here actually from the article. Um, and because it didn't tell me a spectral type for the star, and it said that it was young, it still wasn't really quite clear whether or not it was a main sequence star or not a main sequence star. But based off of what I've just read online, it's a Titori star, which means it's probably its pre-main sequence. But so the researchers plan on using the ALMA, so the Atacama large millimeter slash submillimeter array, which is a radio interferometer, to be able to study this system, or better yet, they've used this instrument, and then that's how they were able to discover the other three planets due to the fact that they've carved out those circles in the disk. And so right, the star Ci Tau is located about 500 light years away. Four different planets. They greatly differ in their orbit, and so the closest one, which is the hot Jupiter I was talking about, is basically has an orbit that's equivalent to that of Mercury relative to the Sun for our system, and the farthest one is about three times the distance away from its host planet, host star, um, compared to the distance between Neptune and our Sun. Now, another thing that they note here is that around only 1% of stars that host hot Jupiters, but most of the known hot Jupiters are hundreds of times older than Ci Tau. So that's the reason why this particular system is like very interesting. Is that you have this very young star, and it already has a hot Jupiter, and so I'm assuming now that this particular system is going to be a very important system to study because it'll probably shed some light on how you produce hot Jupiters. And so, as I stated earlier, though, I mean today's news update is very very short for both stories actually. Um, and I guess I'm just gonna just open up the chat for questions and answer away. So I believe the idea is that the sun at one point was a Tatori star. Um, is that the only type of pre-main sequence star? I'm not too sure. But I do, if I'm remembering correctly, a T Tauri star is a pre-main sequence star. In fact, let me look that up because I'm just saying that, and I could be very wrong, and I don't want to be giving out wrong information here. So yeah, these are they are pre-main sequence stars. And so, how did they find a star 3 times the distance to Neptune? So yeah, according to the article, the way in which they were able to find it was using the ALMA instrument, to be able to study or to look at the ice and dust, within the protoplanetary disk around the star, and they noticed that there were well defined rings within the disk, and those rings would have been due to fairly large planets, and so that's how they were able to find the planets, including the one that's farthest away. But yeah, guys, not really much news articles for today actually. Oh wait, I do see that one more just popped up. I didn't get a chance to really read it. Something about the Chandra operations resuming, and that I guess it's no longer within safe mode. No, we didn't say anything about Voyager Paranor. Yeah, actually, I think last week there were 2 instruments in safe mode, right? There was the Chandra in safe mode, and then Hubble was in safe mode. That's a good point, Guido. Sometimes no news is good news because many times news can be bad. So we don't want bad news. I agree. Losing Hubble would definitely and Chandra would definitely suck. Um, I mean, Hubble's been just been a champ, and just well past, I believe, well past its the amount of time that it was originally thought that it was going to last, to be able to do observation. So it's definitely hanging in there. But yeah, that's the news stories for today, guys. I wish it was a little bit more exciting. And when I first saw these stories, I was trying to think. I was thinking about probably doing like a problem like I typically do, but today I just didn't have really much time, unfortunately. How many scientists do I think Hubble and Chandra represent? Um, I'd probably say a lot, a lot of scientists. Um, I was no, actually, I wasn't. I was getting ready to say that I worked with someone at one point. It was working with Chandra data, but no, it was with Swift data. So, but yeah, I would probably say a lot of people. I've worked with on the Hubble and Chandra projects. Yes, new hardware, that's running faster, has more capabilities is always better, of course, for being able to get better data. So yeah, definitely, as I mean, if they're willing to invest the money, that is, the government's willing to throw the money our way. I mean, we'd be more than happy to take it and build the new telescopes that will allow us to get more precise data. Well, guys, if I hope I haven't missed any questions here. I'm gonna quickly scroll up and see if I may have missed anything. So Adam's asking, does the health of the current space telescopes affect plans to build new ones? Um, I honestly, I really don't know. I don't keep up that much with what's going on with the telescopes. A lot of my time has been invested in just trying to get this paper this paper I'm writing done. But I would assume that if you don't have to invest money in the current space telescopes, like to service them and stuff like that, I mean that frees up money for other things. Haha, that's a great question. So Hanny's asking, what telescopes do I use for work, for my work? So at the current moment, and it's very funny. So my training's in high energy astroparticle physics, and my research was initially in, or my research for graduate school was in studying ultra high energy cosmic rays, where I was observing or analyzing data that was observed by the Pierre Auger Observatory. Um, Not really quite a telescope, but it observes high energy events that enter our atmosphere. Now, the current work that I'm working on is looking at lunar data, or more specifically, looking at the crater markings that have been done by citizen scientists like you guys of the images that we have on our crater projects. And so I guess the instruments those come from are like the Lunar Reconnaissance Orbiter, or some of the other images are coming from other satellites that are orbiting other planetary bodies in our system. So LRO is still rocking it. That's right. And so I've had the pleasure of learning a lot more about about a few satellites, at least. Definitely the Lunar Reconnaissance Orbiter, as the paper I'm currently writing is, it uses data that was taken by that particular satellite. So wait a second. Huh. Oh, Hanny. So Hanny's asking, what is your opinion of the balloon that found the high energy cosmic ray that came from the wrong direction? That's interesting. Um, I'm not too sure I understand what you mean by that, Hanny. Do you by any chance happen to have a paper that you can link me to? Because that's actually very interesting. Well, so the the highest energy cosmic rays are, it came through Earth. So it was that's kind of weird to me now. That's actually interesting and weird altogether. If you by any chance happen to have a link to an article that talks about this, definitely send it my way. Because now I'm very much interested in this. I think it's kind of hard for me to think about how a cosmic ray, um, which are generally just thought to be charged particles that originate from sources in our universe, how it could be able to pass through the atmosphere on the other side of the planet, make its way through the planet, and then I guess produce a shower coming out of the ground, that we were able to detect. So, see, neutrinos are different though. So neutrinos aren't really considered to be cosmic rays because they're not charged particles. However, we do expect for them to probably come from the general directions in which we observe cosmic rays. But yeah, I mean, neutrinos are passing through us like constantly. But definitely, I really want to see about this article. I mean, if you're actually and I don't know if you're on the Weekly Space Hangout Cruise Slack, but if you are, by all means, Hanny, please send me the article. Thanks. I think I'm seeing it. Let's see. This is it. Thanks, Paranor. Observation of an unusual upward going cosmic ray like event in third flight of Anita. Oh, I'm definitely reading this. Oh, and this is like just recently submitted. So that's probably one of the major reasons why I haven't known about this is because, like I said, lately I haven't done a lot of reading, or lately I've been very busy with trying to get this paper done, and so I haven't really read anything outside of um, understanding how to analyze lunar data. So, but I'm definitely gonna take the time to read this though. Well, guys, the time is now roughly like 12:30 p.m. my time central, and so as usual, I love the fact that I can be able to come here and speak with you guys about these interesting topics, and also was able to pick up a paper on cosmic rays in the process. So thanks, guys. Um, I will be back. At least I believe Pamela should be back tomorrow. So Pamela will be taking back the reins for Daily Space. Um, but I look forward to Wednesday coming up with a really good problem. And it might, if I mean, looking at this paper, I might do something with cosmic rays because this is interesting, actually. Um, and so I look forward to seeing you guys then. I'll see you at the Daily Space. I'll see you after Daily Space on Wednesday. All right, guys. Bye.